Hello, my name is Alex, Alex Landis, and today I will be doing a video presentation over emergency descents. And as I said, if you've watched any of my other videos, I'm kind of getting over a flu/cold situation, so if I'm coughing, bear with me and I hope it doesn't bother you too much. But anyways, today we'll be going over emergency descent, and this is a very, very simple but very, very necessary operation that we need to learn as pilots in general, and definitely at Purdue emphasizes this a lot actually. In this presentation, again simple, but I would show a YouTube video by Mike Zero Alpha, but for the sake of time and for the sake of this presentation, I will spare you that. But after watching this video, he kind of goes through what an emergency descent looks like and why we do it, right? And it's a relatively short video, and he demonstrates what it would look like and how we would how we would operate this. But the biggest points of emphasis are the whys, which I want to kind of touch on and highlight throughout this video demonstration, or not demonstration, but presentation. And a big emphasis, first of all, is why do we do it? Why do we practice emergency descents? For a private or a commercial applicant, like the simple answer is, well, whenever we're in an emergency, whenever we need to get on the ground, or whenever we need to get to a lower altitude. And in simple terms, that is correct. Whenever we're in a situation where we need to get on the ground, this is when we will use emergency descent. Typical things that we can look at for an emergency descent is depressurization, right? Like, and for higher category aircraft, whenever they're at flight level 410 or some obscure high altitude and they lose pressurization, yes, they'll put their oxygen masks on quickly, but in order to get to an environment where they can solve the problem or adequately address the problem primarily on the ground, they're going to need a way to get onto the ground as safely and as quickly as possible, right? The same can be said about general aviation, right? There are instances where we might not have a pressurized aircraft, we might not be in an aircraft at altitude, but there are situations where we will need to get on the ground. God forbid we ever experience these issues. A couple of them are engine fire or electrical fire. And at Purdue, these are checklist items that have to be memorized, because in a situation where we have an engine fire, we need to know what to do off the top of our head, because we might not have enough time, or we might be wasting valuable time pulling out the checklist as opposed to actually knowing it. So homework that I would assign either prior to or post this discussion, depending on where we are in our flight training, would be to look over these checklist items that Purdue has for engine or electrical fire and memorize them, right? So for an engine fire, we have FTM, FA, or FH, sorry, is what I like to remember it. So F, fuel selector. So on an emergency engine fire, we have fuel selector off, right? And then the T, we have our throttle closed, right? And M, we have our mixture primed, like idled and cut off. And then the FH is the fuel pump, right? And the fuel pump we're going to turn off as well. And the heater defroster we're also going to turn off. And if the fire still persists, then we will use excessive air speeds to bleed off, or to try to douse out this engine fire, right? And walking through each and every one of these items, why do we turn the fuel selector off? Why do we close the throttle? Why do we cut off the mixture? Why do we do each one of these things? And if you think about it, what does fire need to thrive? What does fire need to build or to survive? It needs oxygen, right? Fuel and heat. So with the fuel selector turning it off, we're attempting to cut off that fuel source for the fire, right? So fuel selector off, right? We want to cut out that fuel source for the fire. For the throttle, for closing it, what does the throttle do? This is, at this point, maybe an early applicant as a private. I would not necessarily expect to understand this. But definitely for a commercial pilot, you should know that the throttle adds air, right? Adds airflow to the fuel-air mixture, which allows the engine to run, right? And that's how the mixture we use to prime more fuel into the system for the throttle, prime more oxygen or air into the fuel-air mixture, right? And that's why when we get up to altitude and we'll lean the mixture, right, for appropriate cruise settings for the most economic fuel-air mixture, right? That's why we prime or we set the mixture at cruise altitude, right? It's not just full rich at cruise altitude because it adjusts and it affects the fuel that we're injecting into the system, the fuel and the fuel-air mixture, right? So we're obviously oxygen, fuel, heat. That's fire, right? That's why we cut it off the fuel selector. We don't want fuel getting into the fire. The throttle, we don't want excess air blowing into the fire and causing it to build more and more and more, right? So those are the first two things we're trying to do. We're trying to cut out the fuel. We're trying to cut out the air, right? And then even for the heater and defroster, later on in the checklist, right? Fuel selector, I cut off, right? Where you turn off, right? And then for the throttle, close it. We don't want air in the system. Mixture, we don't want to keep pushing fuel into the system. For the fuel pump, we don't want to be pumping fuel into the system, right? And then for the heater and defroster, we do not want to cause excessive heat into this in the system. And then for the airspeed as we go down, we're going to want to be within our flaps extended speed because, again, how we're going to bleed off the altitude and get to the ground faster is by being below that flaps extended speed, which in the Archer is 102 knots, right? So as long as we're below that, we're gonna add our flaps. We're gonna add full flaps into the system. We're gonna progressively add those, and then we're going to stay within the flaps extended maneuvering range, which is 30 to 45 degrees, right? So we can either put in 30 degrees of bank and just spiral on down, right? Or if we maybe have a fire in the strobe or the fin strobe lights, right? We're going to want to shake that out and keep that behind the cabin, right? So we're going to deflect the rudder, keep the on fire strobe light behind us, right? And that's an electrical fire, right? So in the engine fire, we're just trying to get down as fast as possible. And if the engine fire persists beyond cutting off all the fuel and air sources and the heat, right? If the fire still persists for whatever reason, we're gonna, after putting in our flaps, remain within the flaps extended speed, but we're still going to try to go as fast as we can within that range to see if we can blow out the fire with the excessive airspeed, right? And then another reason why we would use an emergency descent in a general aviation is just the electrical fire, where we're going to see, okay, well, there's an electrical system that catches fire in our cabin, in the cockpit, right? So first of all, we want to keep in the G1000 system, we want to make sure that we can still have our instruments that are necessary. So we're going to turn the emergency switch on, right? And then we're going to turn the battery and the alternator off, right? So we still have that emergency power, so we still have the systems that are absolutely necessary to flight, right? But we're going to turn off that battery and that alternator, which could be inducing the fire. And those are the three memory items for an electrical fire. And from there, then we pull out the checklist, right? Because in our checklist, this red box is what indicates the items that we need to have memorized, right? So once we have those memorized items, then we can go through, okay, the vents, make sure they're open, heater, defroster, off. Fire is extinguished with the fire extinguisher that is in the pre-flight checklist, right, for flying for the Archer, right? And then we can continue the emergency descent as needed, right? So we've gone through scenarios that we will need to use an emergency descent. So what is the procedure and the entry for an emergency descent? So in an emergency descent, when we're practicing it, we're going to want to make clearing turns. But in real life, we're obviously not necessarily going to have enough time for clearing turns. But in the procedure for entering it, we're going to want to clear the area. We're going to go 90 degrees to the right, 90 degrees to the left, make sure, clear right, left, center. And then we begin to operate this maneuver. And after clearing the area, we're going to have the throttle to idle, right? We're going to take out, again, for either in the case of the engine fire, we're going to have done that anyway, right? That's the second step of our emergency procedures. We're going to take that air source out, right? And then we're going to extend our flaps. That's the next step. So we're going to clear the area. We're going to pull back the throttle to idle. We're going to make sure the flaps are fully extended, right? And then in the entry, we're going to make sure we're banking 30 to 45 degrees within that, while maintaining that flaps extended speed, right? And in the recovery, so that's as simple as it is. We're within that speed. We're within that bank of 30 to 45 degrees as we're getting down to the ground, and then we'll just take it all the way to the ground, right? Either in a field, in a literal field, or at an airstrip, if at all possible, right? Whatever gets us down to the ground the fastest and the safest, that's what we're going to do, right? And then the recovery. For practicing, we're going to get down to assigned altitude, which for the purposes of the ACS and the purposes of overall safety in practicing this maneuver, we don't want to get any lower than 1,000 feet AGL. So for the practice areas around Purdue, it's a safe rule of thumb to assume that the fields in the practice areas around Purdue are 800 feet MSL, give or take. So when we get down to 1,800 feet MSL, so 1,000 feet above the ground's at 800 MSL, 1,800 feet MSL, right? We are going to, when we approach the altitude, we're going to apply the full power. We're going to climb, and once we establish a pitch out attitude, we maintain that altitude. Once we get to the altitude, we maintain it, and we'll gradually retract the flaps and reestablish a positive rate of climb and get to the altitude as desired, right? So to complete this, we obviously need to clear the area, as we talked about. We need to maintain orientation, divide our attention where it needs to be, whether it be the checklist of the memorized items for the specific situation that we're dealing with, right? We're going to want to, when we extend the flaps, we're going to, remember, be below the flaps extended speed, or we're going to be within that bank angle of around 30 to 45, and maintaining a positive load factor, right? And then for the appropriate airspeed, we want to be within 0 to minus 10 knots of that. So we do not want to be above the flaps extended speed, but we still want to be getting down to the ground as quickly as possible. So we do not want to be any lower than 10 knots beyond or below the flaps extended speed, because we're trying to get down as quickly as possible. And then we're going to level off at the specified altitude of plus or minus 100 feet is the range that we can be in. And then completing the appropriate checklist, right? So if we have an engine fire, we do not want to run the electrical fire checklist from memory. We want to run the engine fire and vice versa, right? We want to make sure we're running the appropriate checklist for the configuration or the situation that we are actually dealing with, right? Or that we are simulating, right? Common errors. We need to understand the flaps extended speed. You need to have in your memory bank the flaps extended speed. And to quiz my student, I'd say, okay, so what is that flaps extended speed? And hopefully after I've said it multiple times, they've recognized it's 102 in the Archer specifically. And for whatever other aircraft I might be instructing in, there'd be the appropriate flaps extended speed for that aircraft as well. Improper airspeed control, right? So we're kind of all over the place trying to, like, again, we don't want to exceed the flaps extended speed. We also want to make sure we're at a fast airspeed because we're trying to get either to the ground as quickly as possible, or even in the engine fire checklist, right? We're trying to blow out that fire. And just kind of understanding the situation that we're in. And then leveling above the target altitude is also important for when we practice, right? Because we don't want to be getting too close to the ground for obstructions in the area or things that could endanger our flight. All right, and those are kind of the things that I have to say about emergency descent. We would go out and practice this in an ideal scenario, and we'd have a post-flight discussion going over the ways we can improve, why we do it, emphasizing this is maybe potentially one of the most important maneuvers that we do, because in a situation where we have an engine fire or an electrical fire or any reason why we have to get to the ground as quickly as possible, knowing these items, like the back of your hand, can prove to be life-saving or danger mitigating, right? So we want to know this maneuver specifically as best we can for a given situation when we actually have to use this, that will prove vital to the operation of the aircraft. So that is all that I have for emergency descent. Thank you so much for following along.